So good morning, everyone. My name is Debarshi, and this is Mark, and we work for Bold.com, Bold.com. It's one of the largest online retailer in Netherlands, and we're going to talk about big data as we know it. We're going to our talk is about business intelligence. We're going to talk about strategies and toolings that we use for handling our big data. And Bold.com is, the landscape of Bold.com is moving towards service-oriented architecture or microservice-oriented architecture. So we're going to talk about what is the consequence of microservices on business intelligence, our experience with Hadoop, and some of the in-house projects that we have been doing with respect to business intelligence. So yeah, Mark.
Thank you, Debarshi, for this introduction. Let's start with some figures. At Bold.com, we have about 5.7 million customers. We have 1 million shop visits per day. We have more than 10 million products, and currently we have actually 1,000 employees in Utrecht. And we're doing incredibly well. Can't show you the figures. Our legal department doesn't allow it, but you see where it's going. This is awesome, of course, but it also presents quite a challenge for our IT department because, well, as you can see, this is not a very stable environment we're working in. Everything you build and design here will crumble and crash once you get to here. So our challenge is how can we manage the growth of our IT and of our business at Bold.com? And then you should think about things like, okay, how can we keep our organization manageable? How can we keep our software maintainable? How can we keep our hardware from, well, physically exploding? This actually happened once. And how can we keep our BI architecture simple? Debarshi and me, we both work at the data warehouse team at Bold.com, so our main focus is, of course, on that. Okay, so how do you answer these questions? Let's go back to the beginning. According to Bold.com legend, Daniel Roper started a small online bookstore in 1998 in mobile office unit, not unlike this one. You can say a lot about accommodations like this, but internal communication within such a unit is perfect. Everybody knows each other and they know what they're doing. Your IT infrastructure is simple. You got your server under the desk and it works. When you got your reporting needs, you log into the production database, you copy the data to Excel, and you got everything you need. So this is actually a pretty efficient model for your organization. So when you grow, and that's our philosophy, you want to grow like this. You want to multiply those perfect functional units. So when we're looking for strategies and tools to maintain our growth, that's the model we're looking for. We don't want big things, we want lots of little ones. So when it comes to organization, we introduced Scrum several years ago for our development department. For our software and applications, we've chosen to use microservices to replace our big applications. Hardware, we choose Hadoop because it allows us to buy a lot of cheap hardware instead of having to buy one big, large machine. And finally, for our BI architecture, we invented something we like to call bulk interfaces at Bold.com. Okay, let's start with Scrum. What's so great about Scrum for us? Well, instead of really big development department, we've got lots of small independent software teams. Instead of really big projects, we got like small software increments. And instead of really huge releases, we got small regular deployments. So that's what Scrum has brought for us. Microservices, that's relatively new. We started that, I think, 1 or 2 years ago to replace our big applications with microservices. Okay, let's start. What is a microservice? Microservice is like a container. What does it contain? It contains data. It contains some processing on that data. The container is not visible to the outside world. So you can do whatever you want within this container. You can use Java, you can use Oracle, whatever you want. Providing you maintain a well-defined interface, which is the only entrance for the outside world for this service. Okay, why do we want services? Well, this is our system in 2010. It's a bit schematic, but the idea is you got your IT guy, he's happy because the IT system is not too big, so when something goes wrong, he can fix it, no problem. 4 years later, we grew out of control. Our applications got really, really big, so when something goes wrong with this thing, you got a problem. The IT guy has no idea where to look for a solution, and he's at a loss. So how do we solve that? Well, we divided this big application into lots of little ones we call microservices. And what's so good about it is, okay, if one of these microservices break, IT guy knows what to do because this microservice in itself is not very complicated. He can fix it. All other microservices will stay working because they're sort of independent from that particular one that broke down. Okay, bulk interfaces. Currently, we had a pretty traditional data warehouse on a relational database. We extract our resources from the system as is. Once we get our source data, we do lots of cool calculations and transformations on it. And finally, we load it in a structure that can be easily queried by our end users. And we got a data warehouse team to maintain it. Yes, that's us. Okay, so what's the problem with that? It's not it's a fairly common way of working with the data warehouse. Okay, well, on top you can see all these services, applications. We got your product service, you got your customer service, you got your finance service. And below you guys see all kinds of business users who would like to have data from those services. Okay, and in between you got a data warehouse that has to take care of all of that. I think you can see in this picture already where's the bottleneck. It's in the data warehouse. When I started 5 years ago at bol.com, we had a data warehouse team of 4 people. Currently, we got a data warehouse fleet with 5 teams and 25 people. Our service level hasn't gone up. So we need to do something about it. We need to divide this big data warehouse into smaller units. And that's where these bulk interfaces come in. Okay, still got the service on top, got the business users down below, and in between we got these bulk interfaces. We still got a data warehouse, but its role is not as big as it used to be, because these services have their own business intelligence responsibility. They are responsible to report their data to the end users. And also, the business users, they themselves have their own business intelligence responsibility, because these services will only report on data they contain themselves. So if you would like to combine data from several services, you need to do that yourself as a business user. So yeah, there's still a data warehouse, but its role is smaller, and Yeah, well, other teams and other business units have their own responsibility to get their data into something they can use. Finally, Hadoop. Um, okay, when you got a small business, you need small machines, no problem. When you grow bigger, you buy a bigger machine, more storage, more calculation power. And finally, you get to the biggest machine money can buy at the market. Okay, what happens if you still keep growing? Then this machine is not big enough anymore. Okay, so what do? You get to Hadoop. And what does Hadoop for you? It allows you to scale horizontally. So instead of one big machine, you can deploy a lot of small, cheap machines. And if you still grow further, you could just add some of these machines. Okay, this looks pretty cool. Reality is more like this. Yes, Hadoop scales, but currently a lot of features that you come to expect with these big ass machines when it comes to monitoring, security, connectivity to other systems. Hadoop, yeah, doesn't bring you that. It's quite primitive in that respect. So, okay, how do you solve that? Well, there's of course a little thing we call innovation, and at bol.com, luckily we do have a lot of very talented developers that can create tools to close the gaps that are currently existing with Hadoop. And Debarshi here is one of those people, and he will show you some of the cool stuff we're actually making at bol.com now.
Thank you, Mark. So let's talk about our infrastructure, and architecture from more technical perspective. The picture that you see is actual architecture of our system. So about our Hadoop infrastructure, we have 26 nodes in production. We, as a team, are more or less like a DevOps team. So we deploy using, we build and deploy using Jenkins, and we deploy the artifact using Rundeck and Puppet for managing the configurations and stuff. But first, I'm assuming that people here are aware of MapReduce framework, because Hadoop comes with the MapReduce framework. It's a data processing framework. MapReduce is like a functional programming terms, and we use a lot of HBase. HBase is a key value store, data store. Basically, from a developer's perspective, you can look at it as a map, where we have a key and the values are like fluid. You can add as many columns as you want. Nulls are stored for free. So basically, these are the two things that we use a lot. So so Mark talked about bulk interface. So in the underline, how it actually looks like. To be honest, like bulk interface is basically a data sharing interface between different services, where you can share data in bulk. That's why it's called bulk interface. It basically, in our infrastructure, it consists of two tables. One is basically a versions table, which is basically which contains all the events that are stored, and the other table is the normal table, which is basically the final state of the event. Something like this. So the versions table has a time component to the key of the HBase, whereas the final state is basically the final state of that event, or in this case grouped by the functional key. So let's go back to our traditional warehouse. So this is how it looks like. So we had a traditional relational database based warehouse. We used to replicate data. It's a database thing. So you replicate data from your source systems. Then we moved towards message queues. So asynchronous messages were sent to the warehouse. We used to aggregate them together, and we used to run batches using Chronicle. It's a tool for running batch jobs. Then came Hadoop in our infrastructure. One of the key problems of Hadoop is how would you get data in? For that, we built a framework called Eddy. So Eddy so all the services send messages to Eddy, and Eddy is a framework in between that translates the messages into HBase insert statements into different bulk interface tables. So that's how services send data to Hadoop. So once the data is in, we use pig-based processing scripts that basically processes the data, and the jobs are scheduled using rundeck. And then once we have processed and persisted the intermediate state in the HDFS, in Hadoop file system, we scoop them to the warehouse, and further processing, if required, is done in Oracle. So it looks, so basically there are 3 stages. One is services to Hadoop, data is sent from Eddy framework to the intermediate Hadoop. And then in Hadoop, we use pig, sqoop, and rundeck to process our data. And then once the data is in, we use, if any further processing is required, it's done, and otherwise it's directly reported. But what we actually observe is that in the intermediate state, you end up writing a lot of shell scripts and procedure calls, and it kind of gets messy. So imagine this, we are scaling our services. It's for doing this for every service is very difficult. So we started looking for data design patterns. So 2 patterns that we discovered was the delta pattern. It's a very common data warehouse thing. So you work with deltas in data warehouse. The other pattern is basically lookup, because HBase is really good with key lookups. So you make reference tables. I will discuss this in a few upcoming slides, but we mostly use delta patterns a lot. So in delta pattern, or what we basically assume is that the table is is an event store, and we persist all the events. So in a delta processing, we pick up a delta from the table, we replay the events, and we get the final state, and this final state is persisted in the database. So it looks something like this. So assume that this is the table, and it has a time component in the key. So we would basically take the delta in every run, and we would compute the final state of the data, and then we would persist it to the database. It's as simple as that. But in the lookup pattern, the assumption is that data storing is cheap in Hadoop. So we build reference tables and every delta then looks up in the reference tables, something like this. So let's assume this is the table, and we have a reference key in the table. So we take the delta, we look up based on the reference key in the reference tables, and we basically combine the data sets and join. So we are kind of experimenting with this kind of patterns, but in delta is something we use a lot. So once we have identified these patterns, we started realizing that there are a lot of gaps in Hadoop itself that we would like to fulfill. Because in our original database-based processing, we had a lot of monitoring and alerting systems. So we asked ourselves, as a developer, what exactly insights do we want to see? We want to see process flows, functionally, and how they are running on Hadoop, because it gets pretty complicated. We want to have data quality assurance, because services, are many in our infrastructure, and it can result in data inconsistency. So we want to be really assured about our data quality. Second thing is the data integration problem. Because of the disparate systems across the landscape, it's very difficult to integrate the data. And the third part is statistics about data. So based on these things, we actually made some tools around our infrastructure. So the first thing is called sniff. It's called sniff because it actually sniffs logs. So the problem it's trying to solve is we did not have a very good functional insight into our jobs. You have mappers and reducers, and you can see how many mappers are running, but a single process flow can have multiple map reduce jobs, and you don't really know how much data is processing and how much data is processed out. And also how much time a process flows are taking. So we basically built a tooling around it, which basically collects logs, aggregates at a flow or subflow level. So this is the workflow. If you have a flow, it starts looking at the logs, collecting the logs. You can have multiple jobs, and at one point when you say, I'm done with the flow, it commits these aggregated structured log data into Sniff, and you can use a visualization layer to look at it. So it looks something like this, for example, you have Hadoop and you have different flows. It shows overall how much time it has taken. And if you go deeper, you can see each subflows and how much, actually I can't really show the numbers of records, but it shows you number of records, input, output differences, and so on and so forth. And so it helps you in a lot of ways. Like, these results can be used to generate alerts. These we have future plans of sending it to Graphite or something, so we can have better overview and operational excellence over our jobs. Second part was we started building a project called Kyoto. So problem that we faced was data inconsistency across services. HBase is really good, but because it's fluid, but people can put any kind of data in it, and it's really hard to figure out data constraint problems and so on and so forth later in the process. So we basically, it's a pretty brute force method of doing it, but it incrementally queries different data sources, like different HBase services, big scripts, Hive, HDFS data, or relational database data, and compares the output, compares the diff. So it can be, basically it's a source and target queries, it fires two places, takes the data, diffs, and compares the data quality and just reports. It's as simple as that. These kind of small things gives a lot of insight into your data and can make your life really easy. This is so the next project that we actually did was, it's a work in progress. Is H2O loader. So it's it stands for Hadoop or HBase 2 or Oracle loader. This was the most ambitious project yet. One of the problems that we saw, well, not problems, but when we are scaling at let's say 100 or 200 services, writing pig scripts for each of them is a very painful task. Not just writing, but managing them. So we created a framework which basically, given a service description, it creates the pig scripts, sqoop scripts. This does all the basic ETL, like date transformation, unit transformation, and null transformation, and just puts it in the database. So how does that look? So you have a service definition where you actually define the bulk interface that you want to integrate with your warehouse. You define the primary keys, and then you have a service mapping where you map an HBase column to an Oracle a table column, and what it basically does is it creates a table in your database. And then if it's part of the rundeck schedule, it keeps integrating your data from the service to your data warehouse in a delta pattern. So yeah, so it's kind of in the test right now. So we are working to make it more robust, but it works. So one of the benefits of this kind of solution is that from dev to production time is really quick. You can, by enforcing a pattern, you can predict errors, and if something goes wrong, you know where to look at. When you have pig sqoop, and there are often data type mismatch, there's often data column mismatch, so these kind of errors can be fixed. And services are NoSQL database for us. HBase is NoSQL, so the people who accept these services can actually accept it once it's in our database by querying with normal SQL things, and it can give they can give faster feedback to the service owners. So that's an inherent benefit that we get with this solution. The second thing is more of a prototype and a project. So problem that we saw was accessing bulk interface, accessing HBase is still it's not that perfect in our infrastructure. So we used Huey, and Huey is a framework for is a user interface based framework to access Hadoop stuff, with HBase and stuff. But what we saw was that HBase has a REST interface. So we wrote an HTML, a nice HTML wrapper for these REST interfaces, and it works really faster than Huey in our infrastructure because it's pretty minimum. So you can have a bulk interface for like this, you can see the schema of the bulk interface right away, and then you can have a tabular format. You can filter on the tabular format and things like that. Apart from that, it has the best feature for business users. You can export into CSV, essentially to Excel files. You can create key-based queries. You can order by time, and things like that. So it kind of makes our lives easy, even for analysts. And finally, well, it's a sub-project. So one of the things is that unlike other relational databases where you want to have statistics of data, HBase does have statistics, but from a technical perspective, like more about regions and region servers and so on and so forth. But we did not have more from a data guy. You would like to know how many records are there in this table right away. So we built this bulk stats framework, so it basically every day it takes all the services, checks how many records are there, how much mutations are happening, so on and so forth, and it gives you insights into how fast your data is growing and if you should fix it or not. So for example, this is again, I can show you the numbers, but this is how it looks like. So you have daily row count of a bulk interface or a table, HBase table. You see mutations, how many records are being added that day. And you can actually see some trends, basically. And if there's an anomaly, you can go back to the service owner and say, there's something that's going wrong. So these kind of small projects actually help us a lot. So this is the status right now. So so a few of them are actually in production, and the H2O loader is in test acceptance. So it's going to be in production for certain services. So yeah, so this is how it essentially fits into our architecture. So KIP is something to do analytics on the bulk interfaces, whereas HBase is to just look at the bulk interfaces. We have Eddy for sending data, Kyoto for querying and comparing the services, and we have we use Oracle Business OB for reporting for business. So what did we learn? So, well, one thing that we learned for sure is Hadoop at warehouse setting. It works. We did integrate it with our existing warehouse, and it kind of scales, yeah. Because there are certain services, it's a huge amount of data that they have, and we can work with that. But it's not the silver bullet. You have to do a lot of engineering around it to make it work, and it's open to innovation. You have low level access to your data, and you can do lots of different ways of solving. There are a lot of different ways of solving a problem. So in that way, you have to build solutions around it. And it has traditional distributed system problems. Like, for instance, if some part of the cluster goes down, then there is inconsistency happening in the cluster. And if you don't have a good operational excellence over your Hadoop cluster, it's kind of it's going to give you problems. And of course, the system integration problem between your Oracle or relational database-based data warehouse and Hadoop. So, where are we heading with this kind of with bulk interfaces and pushing analytics towards business intelligence users? We're moving towards making data more digestible, more understandable for IT, non-IT users, and we are moving towards data as a service. So thank you for listening. Any questions? Yeah.
I was wondering, is Hadoop also used in, as the database within Bol.com, or is it just used for BI work?
Well, I can't really tell you with confidence, but I know that Hadoop is used for other kind of stuff, and not just with data. The Hadoop cluster that we have, we share it with other services too. So they, like, I think catalogs or some recommendation service, they use Hadoop for processing data too. So it's not just ours.
That's we got, for example, we got a recommendation service which looks at the web log of our web shop to see what are our customers interested in. So you can understand that that's like a huge amount of data which it has to go through, and for that Hadoop is almost essential. For data warehouse purposes, currently our data is not so big that it doesn't fit into a normal relational database, but that we will reach that point. And once there are more services deployed, we will have more data, and it will grow exponentially. And we need such a large data store as that Hadoop can provide. So, other questions? Sir, yeah.
You talk about that microservices itself provides data to your bulk interface.
Yeah.
Is it real time or
The bulk interfaces are it it depends. The service sends data to the bulk interfaces, and the service owner will decide if that's real time. If an order comes in, it sends it to the bulk interface, or whether it waits and sends it in batch. That's a decision for the service owner to take. Exactly. Yeah. Currently, when from the data warehouse perspective, we load data still in batch. So we get the latest delta in like every 2 hours, every 15 minutes, depends on the kind of data we need. There in the back.
Yeah, I saw versions of the data. Are also versions of the data structure.
Yeah. Well, the thing is with the service interface, it has to be well defined. You have to know what the service is providing, and the same goes for such a bulk interface. So if the structure of the data is changed in a bulk interface, for us that's a new version of that interface. So and then it depends if they just add some attributes to the interface. That's not a problem, because everybody who is using that interface will still have, their applications will not go down. But if you change some existing attributes, then you need to provide a new version of that interface next to the original one, and then slowly the first one will be deprecated. So there. Sir.
The tools that you develop, Sniff and Kyoto, are those publicly available? Do you plan to?
Well, we're maybe you can answer that.
Well, I'm probably not the right person to say that it will be publicly available, but right now it's very it's ours and it's internal stuff. But I think it's built in a way that it can be publicly available.
Yeah, and bottom line, I mean, Bol.com is we owe a lot to the open source community using Hadoop and using stuff like Pig and everything. So yeah, we are very much willing to do something back to that community, and but currently the state of our software is not so developed that we're confident enough to get it out into the community yet. But when it's up to us, we will provide these tools once they're mature enough for our liking. Fair?
You spoke about Eddy.
Mm-hmm.
I didn't quite understand it, but is it something like a database driver? What was Eddy?
So it's essentially a message queue. It takes an XML message and it has a algorithm that parses the XML message and parses it into two different tables. That's pretty much it does, but it does it at a scale.
Yeah, and the thing which makes it for us very useful is, traditionally, bol.com used to be a very database-oriented company. So I got a lot of database developers, and Hadoop is of course more Java based. So Eddy allows our Oracle developers sending data to the Hadoop cluster without having to dive into all kinds of new technologies. So it's very useful for us. Yes. Oh, yeah.
About the data inconsistencies with the Kyoto, we are trying to monitor it.
Yeah.
We're also trying to fix.
Well, right now it's not really fixing it. I mean, if you see this and you send this back to the service owner to fix it, we don't want to fix a bulk interface that's owned by someone else. But in future, there will be notifications. I don't know if that's in the roadmap to fix the data automatically or something with some logic. I don't know that, but right now it's just alerts that we send back. Or
Yeah.
we will be sending.
And we also use Kyoto to check. We do, of course, a lot of ETL processing, getting data from sources, do all kinds of stuff with it, and then send it to our business users. We would like to know if the data we send to the business users is still correct and corresponds to the original source data. And that's why we use tools like Hadoop. When we aggregate, for instance, all order items to a certain level, the numbers should still be the same as the original source. And Kyoto helps us do that. So.
Your custom built tool, Sniff.
Yeah.
Why didn't you choose to buy some logging framework?
We do have a logging framework, but this is not just logging framework. It's parsing very specific things like input records, output records, and stuff like that. And I'm not really sure if you can do that with Kibana or with Logstash or something. So it's very specifically built for these kind of stuff.
It was originally. We have got like all these ETL processes from get data from here to there and then move it from to there and then pass it to the database or whatever. And we would like to have some logging to see how long does these processes take. And we want our functional application maintenance engineers to see immediately if something went wrong with a certain part of that process. So it's more like an abstract, more functional layer on top of the Hadoop logging.
And to elaborate your answer, the people who monitor these things are more of business users, so they are not really used to Kibana or interface, for example. So they are happy with this because they see it in a native, their own comfort thing. So.
Yeah, but it's a trade-off.
Yeah, well.
Buy something that you have to maintain.
Yeah, that's true. But of course, we're in a very fortunate situation. We got quite a lot of developers present at bol.com. So for us, it's always when we ask ourselves, do we buy the tool or will we build it ourselves? Yeah, in some cases, the external party will win and then we buy something. But in a lot of cases, when we can build it ourselves, so why not? And it's fun.
Well, most of the projects actually started with an internal hackathon or something, and we then built upon that, and it's a good culture within the company. So actually, most of them, actually all of them, started as a hackathon project.
So, any more questions? No? Then, well, I thank you very much for attending at this very early age.